So we are going to be talking today about the Cauchy Euler equations. That's section 6.1 of your book. And Cauchy Euler equations, the homogeneous equation is of the kind ax squared y double prime plus bx y prime plus cy equals 0. Notice that the second derivative is multiplied by x squared. The first derivative is multiplied by x, and a, b, and c are constants. This is what we call homogeneous Cauchy-Euler equation, the second order. You can have third, fourth, fifth order, and so on. How do we solve such an equation? The method here recommends to look for x to the power m as solution. Why? Because when you take the derivative, you get one power down, you multiply by x, you reach back to the same power. That's the same method that was used for exponentials when we didn't multiply it by x and x squared. So here, and this is not needed, when answering questions. I'm just explaining here. So I said you need to look at x to the power m, and therefore x times the derivative of x to the power m is m x to the power m, and then x squared times the second derivative of x to the power m is m times m minus 1 times x to the power m. So the function, the derivative times x and the second derivative times x squared, all are factors of x to the power m. Therefore, when you plug them in the equation, power x to the power m cancels, and you obtain an algebraic equation that you solve for m. So this leads to a m minus 1m plus b m plus c times x to the m equals 0. This is the thing, right? And that's the reason why to answer such a question, you will start by going the first step, right? The Cauchy-Euler equation in this case is a m squared, that's m times m's a m squared plus b minus a, b minus the a from here, m plus c equals 0. So this is where you start solving that problem. The big difference with the homogeneous problem is that instead of b here, you got b minus a. That's what makes the difference between the Cauchy-Euler equation and the homogeneous equation with fixed coefficients. In the Cauchy-Euler equation here, the Euler equation has coefficient b minus a instead of just b. And so you solve this, and then on step 2, you write down the answer depending on, step 2 depends on the case. There are 3 cases. 1, 2 distant real roots. If you get two distant real roots m1 and m2, then your final answer is y of x equals c1 x to the power m1 plus c2 x to the power m2. In the second case, if you got two equal roots, or what I call repeated root, then in that case you got y of x equals c1 x to the m1 plus c2 x to the m1 natural log of x. And in the case 3, if you have two complex conjugate roots, alpha plus minus I beta, then you get y of x equals c1 x to the alpha cosine of beta, cosine of beta natural log of x plus c2 x to the alpha sine of beta natural log of x. So this is what your final answer would look like depending on the case, 3 cases. That's it for the homogeneous problem. Example 1. Let's say we have the problem x squared y double prime minus y equals 0. Actually, minus 2y equals 0. So in this problem, you would say, first step, write down the Euler equation. X squared y double prime, that means the a is 1. So here that you get m squared plus b is the coefficient that is in front of x y prime. There is no x y prime, so b is 0. Minus a is 1. So m squared, because coefficient 1, plus b, which is 0, minus 1, m, plus c, which is minus 2 in this case, equals 0. So the equation is m squared minus m minus 2 equals 0. And that's a quadratic equation, so you use the quadratic formula to solve it. So m12 is minus 1, that's 1, plus minus square root of 1 plus 8 over 2, which is minus 1 and 2. So the two answers are minus 1 and 2. They are different. And because they are different, the answer is y of x equals c1 x to the minus 1 plus c2 x squared. I'm going to have an example too. X squared y double prime plus xy prime plus 4y equals 0. So this was step 2. In step 1, you write down the Euler equation. A is 1 because the coefficient here is 1, so that's m squared plus b here is 1 because that's the coefficient of xy prime, b is 1, minus a is 1, m plus c, 4, equals 0. So that's m squared plus 4 equals 0. And this gives you those are complex conjugate numbers. M12 is plus minus 2i. So the answers are 2i. So this is the case of complex conjugate roots. Alpha is 0. The alpha here is 0, which is the real part, and beta is 2. So the answer is y of x equals c1 cosine of natural log of 2 natural log of x plus c2 sine of 2 natural log of x. That's it. Now I'll let you guys do this example 3. X squared y double prime plus 5xy prime plus 4y equals 0. It'll take 5 minutes to think about that. Who has it?
I have the
I have
answer.
the answer.
Let's go. Step one.
It's sorry, I'm echoing. So out the a value is 1, so it's m squared plus, and then in parentheses it's going to be b minus a, so 5 minus 1
Mhm.
times m plus 4 equals 0.
That's m squared plus 4m plus 4 equals 0. And the answers are m1, 2 equal
-2.
-2.
And that's a repeated root, so the answer is
Y of x
Y
is
of
equal
x is
to.
equal to
I'm sorry. C1x to the -2 plus C2x to the -2 ln x.
that's it. And you can see that this is a pretty straightforward topic. No gambling, no doubts. You know the formula, you write it down, you get it, that's it. Doesn't take like 3 minutes to solve a problem here if you know what you're doing. We have 2 steps. 1, get the Euler equation, solve it. 2, write down the answer. That's it. Any other questions on this topic? No? You guys sure? Somehow I have 6 students that have not been showing up for lectures for 2 weeks already.
Did they forget to drop out of the class?
They didn't drop because I can see that they are still in it.
That's weird.
Well, I don't know. Maybe they just think coming now is optional and they just watch the video. Provided that they do watch the videos. All right, so if no questions, let me look at the next part of this non-homogeneous equations, which is kind of a combination of the previous 3 topics. Meaning what? Meaning that the non-homogeneous equation is going to include what we just covered, Cauchy homogeneous equation, and variation of parameters or method of undetermined coefficients. And now in this topic, it's going to be up to you whether you master that topic or not, because nobody is going to tell you how to solve the non-homogeneous Cauchy-Euler equation. It will be given, and after doing the first step, it will be up to you to choose what to do. And if you didn't practice enough, then you'll be trouble. So part 2 of today's lecture is non-homogeneous Cauchy-Euler equations. So those are equations of the kind a x squared y double prime plus bx y prime plus cy equals f of x. And I say the whole theory here is in 2 lines, right? Steps, but it's 2 lines, but each of them is a huge gun, because if you don't know what it means, then it's not going to work out. Step 1 is solve the homogeneous problem, which is the whole thing we just did. That's step 1. Step 2. The variation of parameters or method of undetermined coefficients. That's it. And then when you do this, this is to find yp of x. When you solve this, it's to find capital Y of x. And in third step, you have your answers y of x equals capital Y of x plus yp of x. That's it. So three steps in here. Now, one thing that I can explain here is how do you do variation of parameters and how do you do undetermined coefficients for this specific problem. So we are going to cover that on specific examples. So to do the method of undetermined coefficients, it is necessary to reduce the equation to an equation with fixed coefficients. So in this case, if we want to use the method of undetermined coefficients, then we need to reduce this equation to an equation with fixed coefficients. How is that done? That is done by having a substitution. We substitute. This is done via x equal e to the t, or t equals natural log of x. So we do this substitution and we use t instead of x in the equation. When you do this, you figure that dy over dx is equal to dy over dt times dt over dx, and this is equal dy over dt remains as in the equation, and then dy over dx, first of all, is the y prime that is in the equation, and dy over dt remains as the new derivative that will be used in the solution. And dt over dx, if this is t equals natural log of x, dt over dx is 1 over x. So this is 1 over x dy over dt. And this leads to x dy over dx, which is nothing but dy over dt. So what stands in the equation as x dy over dt, or x y prime, it's the same notation. X dy over dx is same as x y prime, and we just shown with this substitution that that is actually equal to derivative of y with respect to t. So if we replace this by that, we will remove the x, and therefore we will have a constant coefficient for dy over dt. The second would be that if we go now with second derivative, if we take d2y over dx squared, that is going to be the derivative with respect to x of what we just found, which is dy over dt times 1 over x. All right? And that's a product rule right there. First of all, same as d over dx up here, it's going to be 1 over x times the derivative of what is inside. So it is 1 over x, derivative with respect to t of dy over dt times 1 over x. And so that is 1 over x. And this derivative, that's a product. The derivative of a product, we can use the product rule. That's 1 over x times the derivative of this, which is second derivative of y with respect to t, plus derivative of 1 over x, that's minus derivative of x with respect to t. What's the derivative of x with respect to t? Right here we got it. Derivative of x with respect to t. X equal e to the t. Derivative of x is e to the t, right? Which is x still. So derivative of x with respect to t is x divided by x squared, because it's the derivative of 1 over x, and then times the function that was here, which was dy over dt. This is the product rule we are applying. And so when you do this, what you obtain is that this is 1 over x squared. This can come out times d2y over dt squared minus dy over dt. So what stands in the equation as x squared dy d2y over dx squared is d2y over dt squared minus dy over dt. That's same as what you see as x squared y double prime. So the x squared y double prime in the equation, which is x squared d2y over dx squared, is nothing but second derivative with respect to t minus first derivative with respect to t. So if I replace also x squared y double prime by this quantity, then the entire problem doesn't have a product by x anymore. So what we obtain, I'm going to write that here on the side, that when we do this substitution, what we get is a, and then the quantity we found down here, which is this. That's a times this, d2y over dt squared minus dy over dt plus b times the quantity we got here, it's dy over dt, plus cy equals 0. Notice that this thing is nothing but a d2y over dt squared minus a, or plus b minus a dy over dt plus cy equals 0. No, sorry, and actually the right hand side I was writing equals 0, but it's not 0. It's f of x, and x is e to the t. Okay. All right. The right hand side of our equation is f of x, and x is, as said here, e to the t. So that's f of e to the t, f of e to the t. So notice that this equation now is second order linear with fixed coefficients. The entire topic of last week. So if I want to do the method of undetermined coefficients, what I need to do is to do this substitution. And again, in solving a problem, I don't expect you to do the derivations that I did on the side here. I just use that to prove this statement, why the equation will be written like that. So you can just start from here when you're answering the question. Just write this equation in and start solving it. All right. Any questions on this before we do the examples? Any questions? No. Silence. Okay. Let me give you an easy one then. We have x squared example 1, x squared d2y over dx squared plus 10x dy over dx plus 8y equals x squared. Let's say this is the equation that we have and we need to solve. So step 1, we say we solve x squared. Here we solve x squared d2y over dx squared plus 10x dy over dx plus 8y equals 0. That's the equation that we are solving, the homogeneous problem in the first step. And for this problem, we write down the Euler equation. That's m squared plus 10 minus 1 m plus 8 equals 0, which gives you m squared plus 9m plus 8.
Plus,
So, thank you. That's where we are now. So, and we solve this. Of course, you can use the quadratic formula to solve that, and you find minus 1 and minus 8. So, m12, -1, -8 are the numbers that you get. So, capital Y of x equals C1 x to -1 plus C2 x to -8. That's the solution of the homogeneous problem. Then we go to step 2, and I'm going to use undetermined coefficients just to apply what I just showed you. And to use the method of undetermined coefficients, you need to write down the equation that you get. So what we just saw is that it's going to be d2y over dt squared plus b minus 8, 10 minus 1, the same equation, right? dy over dt plus 8y equals f, and for this, you're going to set x equal e to the t, right? So, and f is x squared. F of e to the t in this case is e to the t squared, which is e to the 2t. So this is the equation. d2y over dt squared plus 9 dy over dt plus 8y equals e to the 2t. Notice that we already have the solution of the homogeneous problem there, okay? And the 2 you have here is not any of these powers. Therefore, we don't need to multiply by x. That's the case. Those are the cases of the method of undetermined coefficients where you need to check alpha, right? Because x being e to the t, here I can just replace x by e to the t and see the corresponding solution there. So because 2 is not solution of the Euler equation, we have to find yp of x, yp of t, because it's a function of t, equals a e to the 2t. Why? Because here we got a polynomial of degree 0 in front of exponential. Polynomial of degree 0 is just a constant. No need to multiply by t because 2 is not a solution of the homogeneous equation. That's it. So this is all you need to do. Find that a. And this is why it would be good before you get to this lecture to have done already the homework part that is related to that, because it's helpful. Derivative, you get 2a e to the 2t. Second derivative, you get 4a e to the 2t. And now you can track the coefficients. Second derivative, it's 4a plus 9. First derivative, that's 2a plus 8 the function originally a equals right hand side 1. So you get 9 times 2, that's 18. And 4, that'd be 22, 30. So a is 1 over 30. Therefore, you get yp of t equals 1 over 30 e to the 2t, which is nothing but 1 over 30 x squared, because x is e to the t. So your final answer in step 3 is y of x equals capital Y of x plus little yp of x. And that is c1x to minus 1 plus c2x to minus 8 plus 1 over 30 x squared. Questions? No. It is very easy, right? Okay. Now you do the next one. Exercise 2. Let's say we have x squared y double prime minus 3x y prime plus 13y equals 4 plus 3x. All right, take a few minutes to work this out, please. Anyone with good ideas? Cooper?
Sorry. Oh, sorry. I'm getting feedback. I'm still working. I'm not confident in my process, honestly.
Want to try that code?
Did you say Dakota?
Yeah, I say I'm asking if you want to try.
I got the capital Y.
Yes, go ahead and let him show him. Give me what you have there.
I got M squared plus parentheses 1 minus 3.
Problem.
Wait, what's that?
I said there's a problem.
I guess you can do -3 plus 1.
Y plus 1. Formula says B minus A.
Oh, I got -3 minus 1.
All right.
And then plus 13 equals 0.
Mm-hmm. So that's M squared minus 4M plus 13 equals 0. So what are the values of M that you get?
I did the M wrong, so I'm on the quadratic.
Okay, so we get M12 is 2 plus minus 3I. So with these M's, how do you give me the capital Y of X?
That would be C X squared
Mm-hmm.
cosine 3 ln of X plus C2 X squared sine 2 squared. Never mind. Ln of X.
Now, and on this basic example, you can see that if you try to avoid learning what I just showed you in the previous example, you'll be stuck here forever trying to figure out how to do variation of parameters with x squared cosine of 3 natural log. All right? So be very careful and know that the two methods are very important, and you can't escape one because you think the other one is easy. Because there will be a problem in which you try and you see that you just be wasting your time on it. While if you switch to the other method, it will end in like 2 minutes. So in this problem, I wouldn't even dream of doing variation of parameters. Seeing the cosines of natural logs and its x squared, but all of that multiply, I better go and try to do method of undetermined coefficients. So I go to part 2 again. I do here undetermined coefficients. And so my equation is going to turn to d2y over dx squared minus 4 dy over dx plus 13y equals 4 plus 3, and x is e to the t. That's it. You can see it's a simple problem. And for the method of undetermined coefficients, this right-hand side is just perfect, right? It's just two constants that you're looking for. So this is one kind of function, 4. This is another one, 3e to the t. So you have two different yp's to check here. So yp of t, for the constant, it is a constant a. No problem, because 0 is not, e to the 0 is here, and 0 is not a solution of the Euler equation, so we don't have a problem. We just look for a. Plus 3e to the t, 3 is also not a solution of the the Euler equation, therefore we don't need to multiply by an extra t. It's just going to be a constant too, b e to the t. So this is all I'm looking for. Look how beautiful it is. But if I don't do this, if I don't know this, I'm going to go here, try to do variation of parameters and spend my time trying to figure out how some integrals are going to work out there. I don't need any of that. I just need to track coefficients here and find a and b. So that being said, we take the derivatives. The derivative is b e to the t. Second derivative, again b e to the t. So you track your coefficients. You go for the constant 1. In the second derivative, it's 0. In the first derivative, it's 0. And in the original function, that's a times 13. So 13a equals right-hand side 4. So you get a equals 413. Then you go for tracking the coefficients of e to the t. In the second derivative, e to the t is b minus 3. No, minus 4, sorry. Minus 4, which is here. And then you go to the first derivative. And the first derivative, that's 4b plus 13. Original function, that's b, equal right-hand side of the equation. Coefficient is 3. So you got negative 4 plus 1, negative 3. So you get 10b equals 3. So b is 3/10. That's it. So you got yp of t equals a 4/13 plus b 3/10 e to the t, which is 4/13 plus 3/10 e to the t is x. Therefore, your y of x is capital Y of x plus 4/13 plus 3/10 x, where your capital Y of x is given right here. Questions? Life is beautiful, right? All right. Now you try the next problem. Now using method of variation of parameters. We have x squared y double prime minus x y prime plus y equals 2x. But I ask you to do variation of parameters. Anybody with good news? First of all, tell me how you solve here for y1 and y2. What are the y1 and y2 that you get?
Are they both?
Step one. How did you solve that? I thought someone was talking.
Does that m squared minus 2m plus 1?
I always recommend to follow step by step. Make sure you don't get any mistakes. That's b minus a minus 1 and then minus 1. Yes. What are the answers?
They're both 1.
Okay. So the answer is
Y of x equals c1x plus c2x ln x.
okay. So that's the solution of the homogeneous problem. So technically, that means if we want to do the method of variation of parameters, that means that this is y1 and that is y2. Okay. And moreover, we want to make sure that the coefficient in front of the second derivative is 1, which is standardizing. So it's going to be y double prime minus 1 over x y prime plus 1 over x squared y equals 2 over x. So this is the problem that is to be solved using variation of parameter. And for this problem, y1 is this and y2 is that. That's it. And so you are going to write down your system C1 prime, y1 prime, plus C2 prime, y2 prime equals 0. Oh, sorry, y1 and y2 just here. And then the second equation, C1 prime, y1 prime, plus C2 prime, y2 prime equals the right-hand side of the equation f of x. And now you can replace the functions that I needed. That's C1 prime, y1 it's x, plus C2 prime, y2 is x natural log of x equals 0. And then C1 prime, y1 is x. So that's C1 prime, derivative of x is 1. And then C2 prime, the derivative of x natural log of x is 1 plus natural log of x equals the right-hand side of the equation. It is when it's in the standard form, so that right-hand side is 2 over x. Again, you standardize first. That's how you would solve it in this case. And so for this problem, right away, solution is obvious here. W, right, the functions x natural log of x, 1 plus natural log of x. So that's the Vronsky. You multiply, that's x plus x natural log of x minus x natural log of x. So the Vronsky is equal to x. Then you figure that C1 prime is negative f of x times y2 over w and that's negative. F of x is 2 over x. Y2 is x natural log of x divided by w, which is x. So this is minus 2 natural log of x over x. That's C1 prime. And then C2 prime is f of x, y1 over w, and that is 2 over x times y1 x over w, which is x. And this is 2 over x. From here, you integrate to get C1 of x equals negative 2, negative integral of 2 natural log of x over x dx. You can use u substitution here. You use substitution, you integrate this, it's giving you negative natural log square of x plus a constant. And then you get C2 of x. That's integral of 2 over x dx, which is 2 natural log of x plus another constant. And that's it. Done. You plug them into the formula. You get yp of x equals, or just y of x, actually, because we already have the constants included. That's C1 negative ln squared of x plus C1 times x plus 2 natural log of x plus C2 times x natural log of x. And if you multiply this, you're gonna have 2x natural log square minus here, so that's x natural log squared of x plus C1x plus C2 x natural log of x. So that's the solution. And you can see that it includes the solution of the homogeneous problem. That's it right there. Does this make sense?
Yeah, that makes sense.
Any questions though? All right, so technically that's it. And that's all I would want to explain on this topic. And I'll be assuming from now on that you guys are experts on differential equations, except for the last topic, which we will start after test 3. Next week, you have a session that will go over a few problems to get ready for the test, and the test is on Thursday. Also, during that whole period, I will be out of US. I will be back in Cameroon to bury my brother. So, but I will still be available to answer questions if there are. So here we stop today.